And welcome. In today's lesson, we're going to look at homogeneous second order linear differential equations. So this is the form of this type of differential equation. So what you need to do if you are given this type of differential equation and you need to solve, first of all, you need to change it into characteristic equation where the second derivative now is replaced with m squared and the first derivative is replaced by m, and we do not have y anymore, but we only have its coefficient, which is c, and a and b are still there as coefficients of m squared and m respectively. So we can see that this characteristic equation actually resembles a quadratic trinomial. This is a quadratic trinomial, and we know that when we solve a quadratic trinomial, we will find two values of x. So, and we'll call them x1 and x2. So similarly, when we solve the characteristic equation, we will find the value of m1 and m2. So this is what you need to do when you solve this differential equation. You need to be able to find the values of m1 and m2. Then from there, you can then determine the general solution. So you will find that when you find the values of m1 and m2, there will be cases where they are not the same. So we'll call this case now distinct real roots. So this means that m1 is not equal to m2. Then when you find the general solution, you'll say y equals to a e to the power m1x plus b e to the power m2x. So this is the general solution in the case where m1 is not equal to m2. So when we solve that quadratic trinomial again, we'll get values of m1 and m2. So we will have another case where we will have repeated real roots. So this means that m1 is equal to m2. So if you were asked to solve the general solution of that differential equation, you need to use this equation now. A e m1x. So this term is still the same, but the difference is here now. We have b e to the power. It's not be, it is different now. It is bx e to the power m1x. So we have to note that also a and b are just constants. So these two are the equations when you solve your values of m and you find them in those cases. So we will have again, when we solve, we'll have complex roots. So we can see that this is after we have found our differential equation, we'll convert it to characteristic equation, and then it will be, in this case now, bm plus c equals to 0. If we cannot factorize, we will use the quadratic equation. And we know that the quadratic equation, if we are solving for m, it's simply going to be m equals to, we solve it the same way we solve for x. So it's b squared minus 4ac over 2a. So this is the case where we cannot factorize. We will use the quadratic formula, and in that case we will be having complex roots. So when we use that equation, it's negative b plus minus square root b squared minus 4ac over 2a. Then we can divide through by 2a. Then we'll have negative b 2a plus minus the square root of b squared minus 4ac over 2a. This part now will give us real numbers. And then this side here, we will have imaginary number. So an example of imaginary number, it can be actually square root of negative 4. When we punch square root of negative 4 in our calculator, we get that it's math error. But in complex numbers, we can rewrite it like this. Square root of negative 1 times square root of 4. Then the square root of negative 1, we'll call it j. And then the square root of 4 is 2. So when you are solving the differential equation, that part with a real number will represent alpha, then plus minus. That part with imaginary number will represent bj. So in this case, it's actually beta. So beta is actually 2 in this case. Then you will go ahead to solve for the for the general solution. When you solve for the general solution, you have e to the power alpha, then a, this is a, cos beta x plus b, this is b, it's not beta. Then we'll have sine beta x. Then we close the bracket. So you're going to use this formula in the case when you are working with complex roots. So let's look at example 1. So when you are solving these things, you will not be told whether the type of the problem you will have real roots or complex roots. So we will look at the following differential equation. It's 2 d square y over dx square minus 5 dy over dx minus 3y. So okay, it's not difficult. We change this differential equation to a characteristic equation. So it's going to be 2m squared. We replace now dx with m. We get rid of y. We only write its coefficient like we explained. Then we can factorize this, and when we factorize this, we'll get that it is actually 2m 2m plus 1, then m minus 3. So these are the values that we get. And then when we solve for m, m1 is going to be negative 1 over 2, and m2 will be positive 3. So it doesn't matter which one is m1. Someone can say m1 is 3, and then m2 is negative 1 over 2. Then this side we are having distinct roots, and the general solution formula is a e to the power m1x plus b e to the power m2x. Then we'll substitute the values of m1 and m2. Then we will have the following. m1 is negative 1 over 2, then x there, plus b, e, then m2 is 3, then we'll have 3x. So this is the general solution. We do not have to worry about a and b for now because we are only evaluating for the general solution. So let's look at another case now. If we're having, so we'll call this example 2. In example 2, we have the following differential equation. D square y, so we do not have a coefficient this time around. Then we do have the coefficient for dy dx, then plus 25y equals to 0. So this is another example. We need to find the general solution. So we need to first write it in characteristic equation. So it's going to be m squared minus 10m plus 25. So if I find the factors for this, it's going to be minus 5m minus 5 and then 0. Then m1 is equal to 5 and m2 it's still 5. So we can see that m1 is actually equal to m2. Then we will need to remember our equation. I don't think these equations are given. You need to be able to remember them. So we have e to the a to the power, we have a and e to the power m1x plus bx e to the power m1x. m1 is equal to m2, so we will only have m1 there. So let's check this equation. We have the same roots, so this is the equation, so it is correct. So what we need to do is to replace m1. So this is the final, this is the general solution for this question. And we'll have 5x plus bx e then 5x. So this is the general solution of that. So let's look at another case, and this will be the last problem that we are going to look at. So we have example, it's example 3 now. So if we have y double prime plus y prime plus y equals 0. So y double prime is the second derivative, so it's going to be m squared plus y prime is the first derivative, so it's going to be m. Then we write the coefficient of y, which is just 1 in this case, equals to 0. So here I do not know how to factorize for this, so I will use a quadratic formula to solve for the value of m. So when I solve m, I'll find that I have m equals negative b plus minus the square root of b square minus 4ac. Let me just divide 2a both sides because it is dividing throughout. So I can divide it like this in this case. This is still a quadratic formula. Then when I substitute, I can see that here it's a, then b, and then c. And in those coefficients, all of them, they are 1. So the value of b is 1. So I will have negative 1 over 2. The value of a is 1 also. So I will have actually negative 1 over 2. Then plus 1 square is going to be 1 minus 4a times c. It's just going to be 4 because it's still 1. Then we'll have 1. We'll have 2 also there. Then we'll have negative 1 over 2 plus minus square root negative 3 over 2. Then if we continue to solve like we said, so we will write this in terms of complex numbers. So it's going to be square root 3 over 2, then j, because we'll take the square root of negative 1. So we can see that negative 1 over 2, it's alpha, and then square root 3 over 2 is beta. Then when we find the general solution of this, it is going to be e to the power alpha x, then a cos beta x plus b sine beta x. So that is the equation. We have the value of beta, we have the value of alpha. What we need is to substitute in the place of beta and alpha. So alpha is negative 1 over 2. So we have 1 over 2x. A, we don't have it. A is a constant. In this lesson, we're not going to solve the values of A and B. So the value of beta is square root 3 over 2x. We don't write it with the j. We only take the beta part because this is actually beta j, but then we need to take only beta. Then we'll have b. This is b, is not beta. Then sine the square root 3 over 2x. Then I will close my bracket. So thank you. We're going to end here in today's lesson. Thank you for watching. Please like the videos and subscribe to my channel to help it grow. I really appreciate that. Thank you very much. Until we meet again.